Hello, and welcome to the next in my live Sudoku Solve series. First, some quick housekeeping. First, thank you everyone who's decided to watch these videos. I've really enjoyed watching people engage with them. I'm sure it brings me much more joy to see that than it brings you to actually watch them. But anyway, I appreciate it. And I'm thinking about over the holidays doing some type of either best of, something like my favorite puzzles of the year that nobody solved, or something along those lines. And if you have any suggestions for that, or just any other puzzle that you'd like me to solve, please post it in the comments, and I'll take a look and see how it goes. Yeah, so that's that. This morning I picked the puzzle Modular Zipper by GDC. GDC has quite a few puzzles on Logic Masters Germany. I'm sure I haven't done even 10% of those, but the ones that I have done, I've always enjoyed them. They've been lovely. So hopefully this will be no different. And so let's get to it. There are two rules, one of which is kind of trendy, this lavender zipper line. So these zipper lines are basically rearranged arrows. So in the center of the zipper line, you have these circles, and those circles are the sums of the zipper lines. And every set of digits that are equally distant from that circle. So for this zipper line, I've got this pair of cells and this pair of cells. Each of those pairs individually sum to the number in the circle. So for example, if this were a 7, this might be 3 and 4, and this might be 2 and 5, something like that. So that's how those lines work. And then with these modular lines, basically you think of 3 different groups: the digits 1, 4, 7, 2, 5, 8, and 3, 6, 9. I should just do them closer together. Each of these groups has a different remainder, mod 3, and they're all the same within the group. So 1, 4, 7, they all have a remainder 1, mod 3. 2, 5, 8, these have a remainder 2, mod 3. 3, 6, 9, these have remainder 0, mod 3. So these are our 3 groups. I might call them modular groups as we go on through this puzzle. And if we look at these lines, every set of 3 adjacent digits on the line must have one of each group. So if this were from the 1, 4, 7 group, then these two would have to be from the other group. Maybe you have a 2, 5, 8 here and a 3, 6, 9 here, something like that. And one of the kind of tricks here that we'll see is that because every 3 digits has to have one of each group, then if I look at this group, well, this has one each. Well, this also has to have one each. And what is it missing? Well, it's missing the one it kind of gave up here. And so once you know what one group's, if you figure out the modular group of one cell on the line, you can kind of propagate it forward. Every 3 digits on the line will be the same. So that'll, I'm guessing, be a neat little trick we'll end up using. So those are the rules. Go ahead and try this puzzle yourself first, or don't, whatever floats your boat. But I'm going to try it. I'm going to start now. Let's just restart the time for me. Okay, so the first thing I'm going to do is just essentially think of these as arrows, and try to see if there's any strong restrictions on, particularly the sums of these arrows. So, for example, this has to be 7, 8, or 9 because I've got 3 different pairs of digits that all sum to that. So I need at least a 7 to get 3 different pairs. Right? 6 only has 1, 5, and 2, 4. These are all at least 5. I'm not going to mark that. These are all at least 5. This one actually doesn't have that restriction. This could even be, say, a 3, because these pairs don't see each other. Right? I could have a 1, 2, 1, 2, something like that. And that would be fine. So there's really almost no restriction here yet. So that's my first pass. Not so successful, I'd say. Let's look here. This is a little bit interesting because we've got 2 of these modular lines here taking up this box. And for the digits 1 to 9, each group had 3 digits in it. So if I think about any particular group, one of the digits is going to be on this line, one of the digits is going to be on this line, and the 3rd digit is going to be here in between those lines. And so you can kind of think of this as another modular line. And so can I say something about any of these cells based on that fact that these all have to be different. But I can, because if I think about this number, well, it just turns out that this is going to have to be the 3. So in other words, if you think about it this way, I essentially have one number that's 0 mod 3, one that's 1 mod 3, and one that's 2 mod 3. So this, this represents the 369 digits. This represents the 147 digits, and this represents the 258 digits. And, how can I add, in a modular arithmetic sense, how can I add 2 of these together to get the third? Well, 0 and 1 will not make 2. 0 and 2 will not make 1, right? 0 and 1 makes 0. 0 and 1 makes 1. 0 and 2 makes 2. 1 and 2 makes 0. So to have 3 modularly different numbers where 2 of them sum to the other, I can't have 0 kind of as one of the adders, I can't remember what you call those, one of the things that are being added together. Because if you do, the other one will just get it to itself. And just to give an example, like suppose I were to add 3 and 4. Well, I'm going to get something that's the same group as 4. In fact, I'll get 7, which is the same group as 4. Right? So if you add anything of mod 0 to something else, you'll end up with something in whatever that something else's modular group is. So I can't have a mod 0 number here in one of the two digits being added together, because then whatever is here would in the circle would end up repeating in one of those two spots, and that would break here. So this is going to have to be 3, 6, or 9, but it can't be 3 because again, if this were 3, you need a 1-2 pair here and a 1-2 pair here. So that's 6 or 9, which is not getting me quite where I want to go. So, it's something, right? And then these are going to be different modularities as we go through. But I don't see how that helps yet. So let's keep looking. I don't see any other obvious restrictions. I'm tempted to start looking at set. So what is set is this idea that I can kind of shade some cells. Maybe I would make these blue, and maybe I'd make these orange or something. And if I take away the overlaps of these, then the digits that are left all have to, the digits in orange have to be the same as the digits in blue. And the reason that might work here is I've got these zipper lines which are doing a lot of summing. So I'm looking for groups that I can put together where I could do some canceling out of the different groups by sum. Right, so I can't even think of because the zipper lines, it's kind of hard because the sums are not along the line. The sums are kind of these diagonal components of the lines. Or maybe something with this, right? So for example, if this were blue and this were orange, right? None of them overlap, so I can't exactly take them away. But I know that these 2 digits sum to the same 2 as those 2 digits. So I could take them out. And now what's left is, well, it's not true that the orange digits are the same as the blue digits. It might be, but it's not necessarily true. But what is true is that the sum of the orange digits is the same as the sum of the blue digits. But obviously that particular example is not going to help us. But I'm looking for ways that I can use these sums to kind of cancel out. And I'm not seeing anything obvious, or even not obvious. I'm not seeing anything that I can see, I guess, is the way I'll put it. So that is not, I don't think is where we're going to go. Maybe here. So I've got one set of the 3 modular numbers here, one is here, and for this whole set to work, this is also going to have to be a modular set. But this is different than what we just did here, because now this is not the sum of these 2 numbers. This is the sum of these 2, and this is the sum of these 2. So it's not so obvious to me that that's going to matter. I'm just going to go through a couple examples in my head and see what that means. So let's say this were a 5. Then I'm going to need either a 1 or a 4 and a 3. Right? Because I can't put 6 or 9 here, so I'm going to need a 3 in here. So the 3 would pair with 2, and the 1 or 4 would pair with the other. I get 2 in either one. So I get 3 here, 2 here, and then some 1-4 combination on the other. So if this were 6, I'd have either 2, 5 and 1, 4. No, it's either 1, 2 with 4, 5 or 4, 5 with 1, 2. If I've got 7, I would need 3 or 6 with 1 or 4, and then this 2, 5 pairing. Actually, so what I'm noticing is that, I don't know if it's always true, let me think for a second, but what I'm noticing is that in those examples, I never end up with a mod 3 number here. Of course, I can't have a mod 3 number here. What happens if I put a mod 3 number here? If I put a mod 3 number here, then whatever digit here, whatever modularity I have here is going to be the same as here. So for example, suppose this were a 3, right? Then if I make this, say, 7, what's 7 minus 3? It's 4. And 7 and 4 are going to be the same, they're in the same modular group. And that's going to break this idea that these have to all be different. So what does that mean? So that I never end up with a mod 3 number here. And I have kind of 3 different modular lines here. I've got these all have to be different, these all have to be different, and so what's left, those 3 all have to be different. These can't be 3, 6, 9, so this has to be 3, 6, 9. But it can't be 9 because it's on a zipper line, and 9 plus whatever will sum to something more than 9. So this is 3 or 6. So that's 3 or 6. Can I do the same? I can't do the same thing. I was really hoping I could do the same thing over here, because then I would get this is also 3 or 6, and that would sum this to 9. And that would give me a whole chain that would really break this puzzle open. But I don't have the same restriction here because these, I don't have, each of these has to be one from each group, like I have over here. So I don't have the restriction here, so I don't end up with this restriction here. I'm wondering if I can back into it another way. And I'm thinking through so basically I'm trying to contradict. So what happens if this is not 3 or 6? So if this is not 3 or 6, I end up with, 1 in the mod 0, in the 0 group, the 3, 6, 9 group. One of them is going to be here, and then I put 2 here. And actually, does that? I don't. Hold on. I'm trying to think whether that works. So maybe I could have. So if I have, let's say I have 2 of them and neither of them on the bulb. So maybe I've got 1 in this group and 1 in this group. If they sum to each other, I'm going to end up with a third there, which will break this line. So they can't be kind of across the line from each other. If they're like this, then if they're like this, then these 3 will all be the same. So why is that? So let's say these are both from 3, 6, 9. Well, they have to be from 3, 6. Then this would be some. Let's say it's 1, right? Then from whatever modular group this will be the same because 1 plus 0, right, is 1. And the modular arithmetic means this will have a remainder of 1 sum mod 3. And I can do the same thing here where 1 minus 0 is also 1. So this will also be 1 mod 3, and that'll break this. So I can't have the 2 either on the same zip sum as each other. I can't have them on different either. And I don't think I can have them like this because then what do I put here? If this is 0 and this is 0, that also has to be 0, and that will also break this line. So that is really, it's really cool. It's very hard, but it's really very, very cool. And GDC must be some type of mathematician to think that, maybe this isn't on the path. Maybe this is just a weird alternate break-in, but it seems so intentional that I think it must be intentional. But it's so hard that I can't believe they think that's a 3-star deduction. Anyway, well, whatever. We found it. So that has to be a mod 3 number. Again, the kind of short version of that is, if this is not a mod 3 number, or a 0 mod 3 number, then I've got one of those here, 2 of them have to be here, but I can't put exactly 2 on this zipper because either they sum together and you end up with a third, or they don't sum together, but they're still both sums, and then you end up with 3 of the same group, which breaks this line. Or you have 1 as the sum, 1 as the summand, and then whichever one goes across from this also has to be 0 mod 3, which again breaks this line. So this has to be 0 mod 3, which means those are both from 3 or 6 because they can't be 9 because they have to sum together to get something 9 or less. Now you have this 3-6 pair, which sums to 9, which makes this 6. And this is now a 1, 2, 4, 5 quadruple, making this 3, 7, or 8. And this, so, geez, this is now, so I have this modular line here where these all have to be different. But these 2 digits, they can't be whatever this number is. They can't be whatever this number is. So they can't be 3 or 6. And they can't be 9. So they're none of 3, 6, 9. So in this group, the 3, 6, 9 has to go here. And the only one that fits that is 3. Oh my goodness. I mean, that probably is, maybe it's 3. I don't know. I don't know what that is. But this puzzle is crazy. I love it. It's, it's very much modular math. And so if you don't know modular math, I think you're going to have a very hard time with this puzzle. And even if you do, I think it's quite tricky. So let's see, I've got a 7, 8 hit over here. This has to be more than that. So that's 9. And that's going to sum from 1 or 2. Let's think about, so I'm thinking about, can this be, which of these is 3, right? So, okay, it's not, yeah, because we said, right, the 3, hold on, let me think of this. The 3, 3, 6, 9 digits, there's 1 here, there's 1 here, and there's 1 here, right? Because we said neither of these could be, because this, right, this is one of the groups. This has 1 of each modular group. This has 1 of each, and there's the third. So one of them is here. So if this is 3, this is 3, then this is 3. Because basically I have to put a 3 here. None of these are from the 3, 6, 9 group. So the 3 would have to go here. So if this is 3, then this is 3. But that breaks because I can't have 1, 2 in both of those spots. So this is a 6, and this is a 3. Which means I've got a 3 in one of these spots by Sudoku, but not here by that same zipper logic I did over here. And that means this is not 9. So 9 is not anywhere here. So 9 is here. 6 is now the 3, 6, 9 on this line. So it's one of those because it's not on top. Okay, now what do we do? 3. So this is a modular group. Now this is actually also a modular group because, or just more simply, if this is 6, 6 can't go here because to sum to 9, I need to add a 3 to it. So neither of these can be 6, neither of these can be 6. One of these is also 6. And so to sum here, I either have 1, 8, and those are different modular groups, 2, 7, those are different groups, or 4, 5, and those are different groups. So I end up with kind of a modular group here, a modular group here, and a modular group here, which might be fruitful later. So I'll try to keep that. Maybe I'll just draw. Well, no, I don't want to break the print tool out. So this is a modular group. This is a modular group. Or sorry, these are all different modular groups. These are all different. These are all different. Oh, and I can place these, right? So these are a 3, 9 pair, right? So as I said before, if you go 3 away along a line, the modularity has to stay the same. So this can't be 6 because that's 6. So I have now all 3 of these. So these are all kind of the 1 group and the 2 group. The 1 group meaning the digits 1, 4, 7, and the 2 group meaning 2, 5, 8. Oh, but these are actually different. So I know where the 3, 6, 9 group is on this line now. So because these are different, and one's the 1 group and one's the 2 group, I know the 3 group is the one that doesn't touch either of them. So this one touches here. This one touches these two. So the one that doesn't touch, the ones that don't touch either are kind of those. So I have this 3, 6, 9 grouping here. And this isn't 6 because it sees that 6 group. Do I know which way around these go? So this is probably 9, because unless this is 9, 9's going to go on this pairing, and this can't be 9. What if this is 9? If this is, okay, so yeah, so this can't be 9. So why can't this be 9? Suppose this was 9. If this is 9, sorry, this is 9, because this is not 9. So let me try to explain this again. This can't be 3. Why can't this be 3? Suppose it were 3. Well, if this is 3, then this is not 9, because they're 2 digits adjacent on this modular line. They'd be the same modularity. So this, if this is 3, this is not 9. Well, also nothing on the zipper arms can be a 9 because they have to sum together to make something that's 9 or less. So I can't put a 9 on one of this because 9 will sum with something to be more than 9, and that will break the zipper. So if this is 3, this is 9. But then what do I put here? If this is 9 and this is 3, then these are all kind of digits that sum to 9. And the way the digits 1 to 9 work out is that I've got 9 and kind of 4 ways to sum to 9. I've got 1, 8, 2, 7, 3, 6, and 4, 5. And so 3 of those digits will be accounted for along the zipper. And the third one would have to go on this. So if this is 3, that means this is 9, but that makes this 6 to make this sum to 9. And then again, I have the same problem where 3 and 6, well, first of all, this just can't be 6 because of this, but also modularly, they can't go next to each other. So this is not a 3, that is in fact a 9, so that's not a 9. So what's going to go here? So if this is a 7, this is going to be, I don't know. If this is an 8, it's 4. If it's a 7, oh, it's 8. So this is 4 or 8, right? So if this is 7, I can't put 8 anywhere here because I have to add 8 plus something else to get to 7. These would have to be the 3 ways to add to 7, which are the digits 1 to 6, right? 1, 6, 2, 5, 3, 4, in some order. So if this is 7, this is 8. If this is 8, I can't put a 4 on this line because 4 would need another 4 to add to 8. So the 4 would go here. So this is either 4 or 8. So this is not, oh no, that's not right. I was thinking about if this were that, but these are not on the same line. Okay, so any more with that? I don't think so. So there's also a 9 here actually, because this has to have a 3, 6, 9 digit. 6 is here, 3 is here. I need a 9 there. These are both from 5, 7, 8. This one can't be 5 because it has a 3 here, and 5 would need 1, 2, 3, 4 on the zipper. This 6 here means that's not 6, so that's 6. So this is the same modularity as this, and these two are the other modularity. I'm going to think about coloring that. So because this is kind of 0 mod 3, whatever it adds to is going to be the same as this. So these two are the same modularity. These two then have to be the same modularity because I've got 2 here, the third one's on this line. And then what are these? These have to be, so 3, 6, 9 are accounted for. Whatever this is, those 3 are accounted for. So these two have to be the third group, either group 1 or the 1, 4, 7 group or the 2, 5, 8 group, with the third showing up in here. And then there's a missing digit here that's either from the 1 group or the 2 group. And I'm trying to think whether that would pair with this, and then I end up with kind of these being different, or whether this pairs with these, and then these end up being the same. And it turns out, so the missing digit here that's not 6 is either in the 1, 4, 7 group or the 2, 5, 8 group. So it's either going to pair with whatever the modularity of this digit is, or it's going to pair with the modularity of whatever these digits are. And it turns out it's going to have to pair with this, because if it pairs with these two, then all 3 are accounted for. this modularity group is going to be the same as this, and whatever's missing, whatever's not 3 here. But if that's true, then this number will, if you subtract 3 from it, I'm going to get a digit up here that's also the same modularity. So I'll have 3 digits of the same modularity on this line, which is fine, except that would break this modular line because I need 1 for this. So whatever's missing from here, so I'm going to actually color. So remember before we said this was a modular group. So if I call this, I don't know, let's call this blue. Now let's call it orange. Then we'll call this green. Whatever is not in the orange modularity group is in the green modularity group is one of those digits. And that's going to match here, and then these will be orange. I don't know which way these go, right? So this, wait, do I know which way this goes? Yeah, so this is the same as these. No, so this is the same as these two, because I've got these 3 are all the same. So these 2 have to pair up with what's missing, and that's going to go to here. And so these 2 will pair with these. Oops. And now I'm trying to think, like, could those be green? I think the answer is yes. But I don't know. Okay, this is just 3, which I've had for a while. Sorry about that. That makes this 9 and 6. So that means one of these is 3. One of these is 6. This 9 means those aren't 9, so that's 9. Means those aren't 9, so that's 9. Which means 9 is one of these. Actually, that means this is 3. So why does that have to be 3? Well, if I put a 3 on one of those digits, then if I count 3, it happens to be 3, not because this is 3, but because there are 3 different types of groups on this modular line. So if this is a 3, then 3 away also has to be in the 3, 6, 9 group. But this, all of them are taken in this column. Same with this. So 3 away would have to be, these do have to be the same modularity. And 3, 6, 9 are taken here. So neither of these are 3, 6, 9. So neither of these are 3, 6, 9. So my 3 has to go here. 9 is not on this group, so 9 has to be in this modular group. And I know where it is here. 3 has to be on this modular group then, but not in the middle because of this 3. Let's think about this 6, 9, because that's kind of unique. I haven't thought about this. So, well, first of all, the 6, 9 can't be these 2. It has to be 9 and 6, and then that would have to be 3 to make this zipper work. Right, so if these were a 6, 9 pair, then this has to be bigger than this. So it's 9, that's 6, that's 3, that breaks this. So this has to be 6 or 9. And then I think this can't be 6 or 9. Well, it's not 9 for sure. I don't think it's going to be 6 either, right? So what happens if this is 6? Now remember that these modular groups, whatever group this is, whether it's green or orange, also is here. This one is also here. So 2 of them are taken. So whatever group this is has to show up in one of those 2 as well. Not here because that's 6 or 9. So whatever is missing here, whatever this is the 147 group or from the 258 group, the other one, right, that you get one of them here, one of them here, one of them here. All 3 are taken up. So whatever digit's missing here has to be the other modularity as this. But if this is 6, then 6 plus whatever is the same, doesn't change the modularity. So those 2 be the same modularity. So that can't be 6. So in fact, I just have a 6, 9 pair here. And these are just different modularities. So 1 plus 2 gives me 0, 1, 3. So that works here. So these are different. These are the same. These are the same. But I don't know which way around they go, right? These are different. This is this and this. These are the same. So what do I do next? I don't know. Can this be 6? Sure. 2, 4, 1, 5, no problem. Can this be 9? Of course. So what is my next step here? This is not 4 or 8. That's not, I don't think it's worth marking. It's not 4 or 8 because this is a different modularity than this. No, that's fine. What was I thinking? Yeah, no, it could be 4 or 8. Because these 4 and 8 are different modularities. Well, we can go here. This has to be at least 5. But actually it can't be 5. So the reason it has to be at least 5 is because of these. I need 2 different ways of summing to this number, this way and this way. But it can't actually be 5 because 5 would need these to be 1, 2, 3, 4. That would break this. It also can't be 6 because that would break. That would need 1, 2, and 4, 5. So this is 7 or 8. It's not 6 or 9 because of those. And this 9. So do we have a 7, 8 pair here? Which means 7 or 8, 7 and 8 are in those 3 cells. But this can't be a 7, 8 pair. Holy cow. This can't be a 7, 8 pair. Why not? Because they're the same modularity because they're 3 away in a modular line. So this can't be a 7, 8 pair. So between these 3 cells, 2 of them have to be 7 or 8. It's not these 2. So this has to be 7 or 8, with the other one being one of those 2. So now I get a 7, 8 pair this way. More importantly, this 7, 8 means that's 9 and that's 6. And now I get 9 from here by Sudoku. 6 is one of these. So are 9s done? 9s are done. We finished 9s. 6s are not done. No, not. But 6 is one of these. So 6 is one of those. So one of these cells is the same modularity as this 7 or 8. Is that something? Maybe. So do I know which way around this? Sorry, I'm jumping around. I'm jumping around because I'm not gaining much purchase on these things. I'm just trying to kind of look around at different clues and see if I can find something where I'm looking for anything, right? I'm not immediately finding it. So I'm kind of jumping around from clue to clue. So rather than doing that, what was the last thing I did? The last thing I did was I put this 7, 8 here. Right, this is such a beautifully constructed Sudoku that I feel like the next step will just be kind of clear from the last step. So the last thing I did is I put this 7, 8 here, 7, 8 pair here to make that 9. So neither of these are 7 or 8. I got a 7, 8 pair here. So this actually this is the other 7 or 8 because, right, this 7, 8 pair means that's not 7 or 8. We said it had to be 2 of these 3. So this is a 7, 8 pair. That means these are 1, 4, 5, 1, 2, 4, 5 in some order. Actually, this is 1 or 2 from just this sum I've had for a while. So these are 1, 2, 4, 5 in some order. And this is 1 or 2. So can I say? Can I say something about, well, these are different modularities. I'm going to start coloring these. So I had a thought about 9s and these having to be different modularity across 9. So this is 7, 8. This is one modular. I'm going to use green and orange. So let's try purple and yellow. So let's say this is purple. This is the other 7 or 8. It's the other modular group. This is also the other modular group because, right, if these are the same modular group, say 8, 2, that wouldn't be 9. 7, 1, that's not 9. Right, I need 1 and 2 to make 0 in a modular arithmetic sense. This is the same as this one, which means this is purple. And this is also yellow because, again, for the same reason here, to sum to 9, these have to be different modular groups. I mean, it could be 3, 6, but if one's from the 1, 2 group, the other one has to be from the other 1, 2 group to get to 0 mod 3. So this yellow 1, 2 is down here. But where's the purple 1, 2? So we said before, these are all the same modularity. So this is the yellow, what do we have, 4 or 5. And these are both purple, 1, 2, and 4, 5. So purple's actually done here. And this is yellow. And what is this? This could be yellow 4 or 5, or it's 6. So these, but importantly, right, the purple 1 or 2 is one of these two digits. So 1 or 2 is gone from here. So none of these are 1 or 2. They're not 7, 8, 9. So these are from 3 to 6. And so if this is 7, this will be 3, 4. And if this is 8, it's 3, 5. So either way, we get a 3, and we don't get 6. So where does 6 go in this column? It's here. Oh my goodness. And then that tells us this is 6, not a color. That's our green. Now can I do more with this line? So this zipper. So I've got, one of these is 3. So one of these is yellow, actually. One of these is the yellow 4 or 5. Right, so this is 3 and then the purple 4 or 5. One of these is the yellow 4 or 5, which will have to go with, wait, did I do that right? Hold on. Back up. I'm not 100, I wasn't 100%, I had a thought, but I'm not 100% sure it's right, so I'm gonna go back for a second. This is the purple 4 or 5, because it doesn't pair with 3, right? And the purple 4 or 5 is one of, oh no, that's wrong. This is the yellow 4 or 5. Okay, let's just back up. What is this? This is the purple 1 and 2 and the purple 4 and 5. Purples are gone. I just marked this wrong. This is the yellow 4 or 5. Okay, the yellow 4 or 5 is here. So the yellow 1 and 2 and 4 or 5 are down here. But more importantly, yellow is done in this square. And I could have seen that if these two sum together, so one's 3, the other is going to be the same modularity as this. So what is this? It can't be, this doesn't, in fact, neither of these are 6. Because if one of these were 6, then these two sum together to make this yellow number. And if one of them is 6, then the other one would also have to be yellow, right? So 0 plus yellow would be yellow. 6 is 0 mod 3, right? So if one of these is 6, then we get 6 plus the same modularity. So 6 plus, or do a minus. 7 or 8 minus 6 gives me the same modularity 1 or 2. Gives me the yellow 1 or 2, which is already in this square. So 6 can't be here. 6 can't be here. That's 6. And in fact, these are both, in fact, all 3 of these are purple. All 3 of these are purple. So I've got 2 purples, something like this. So that's 7, that's 2, 5, and that's 8. And if that's 8, that's 1, 7, and that's 4. And then, what do I do? 2 purples, yellow. I've got 2 yellows and a purple here. This is a purple, and I'll mark the 3 here, and then one of these is purple. But I know which way it goes, because this 3 means that's not 3, that's the 3. It's not, doesn't have a color. That's purple. Oh my goodness. That is brutal. So now I've got 4, 8 pair here, it makes that 7, and that tells us which way yellow goes. Holy cow. Oh my goodness. And that tells us that's 8, that's 4. So let me back up. This, straightforwardly, this 4, 8 pair tells us that's a 7 just by normal Sudoku, right? But if that's 7, these yellows are the 1, 4, 7 modular group. So that's 1, that's 4, plus 3 and 4 sum to 7. This then is not 4, right? That's 8. And then that makes that 4. I'm going to clean this up a little bit. This is not 1 or 7, right? This is 2 and 5 summing to 7. That's not 7. All these purples, 7s or 8s, are 8s because that's what that group is. That's 7. That's 1, 4, 7. This is 2, 5 in some order. This is also 2 or 5. And now I'm going to get rid of all this coloring because it's all done. And I don't want to confuse it with this green and orange coloring that I also have, because I don't know which way it goes. So this is orange, this is green, but I don't know which way around that goes here. So here I've got 1, 4, and what's missing from this? These two are the same. Hold on. So this modular line is now figured out, at least the modularity. So this is the 0 group, the 1 group, this is the 2 group. That's 2, 5, 8. So that's 1, 4, 7. This is 258. Where? No, that's not right. I feel like such a big break. So 2-5 is gone from this column. 2-5 is gone from this column. So 2 and 5. What is this column? I'm missing 2, 3, and 5. So these are from 2, 3, 5. That's not 3. So that's 7. These are 2, 5. This is 8. Wait, no, this 4. And this 4 tells us which way this one runs. Because remember, earlier we said that this digit can determine what those digits, or determine this digit once we figured out that was 9. So if this was 7, this was 8. And if this was 8, this was 4. So the converse, because the converse, this is the contrapositive, I guess we'd say. This is not 8, therefore this is not 7. So that's 8. So then, let's see. So this can't be a 3-5 pair. So one of these is 2. So this is 3 or 5. I'm just going to mark this. That's definitely a 2. So I have a 2 here. So I've got 2, 2, 2. Oh, and plus the 6 just pairs with this 2. So I have that. The other one is 3 or 5, which is going to pair with the other 3 or 5 here. This is going to be 1, 7. Right. So, and I said this is 2, 5, 8 matches with these. So these are 2, 5, 8. This one's not 8. This, and then these are 1, 4, 7. This one's not 7 or 4, so that's 1. This one's not 1 or 4, so that's 7. That's 4. 4, 4. One of these is 4. Can I figure out, did I get a 3 yet? No, 3 is still any of these. So one of these is 4. So that's not 4, so that's not 2. 7 makes this 1. We know which way the 1, 7 goes. 7, 7. One of these is 7. I feel like we're so close to being done, but I can't. Let's see. I've got one of each of these. One of each of these. What's next? 3, 4, 2, 5, 8, 2, 5, 8. One of these is from the 2, 5, 8 group. One of these is a 1. So these aren't 1. So not 1, 5. So that's 2 and 4. That's 1 and 5. 1, 5, 2 and 5. So one of these is 4, which I kind of knew already. 4. No, I'm not going to mark that. I'm trying to get in a habit of making fewer markings, so the markings I make are more important and will kind of guide me where to go. 3, 4, 3, 2. Can this be 5? Yeah, that could be 1, 2, 3, 4, 7, 8. That's fine. Let's see. One of these is 4. These is 5. Let's see. These are all the same group, so it's either 7, 1, 1, or 2, 8, 5. Or any of these are problems. So let's say it's 1, 7, 1. I have a 1 here. This would be, this would not be 3 actually, this would be 3. So this would be 4, 6, not 6, 4 or 7. 1 with 4 or 7, this would be 5 or 8. This would be 3, so this would be 2 or 5. Well, it should be 2 because this would be 1. 2, 1, 5, 4. Right, right. 1, 2, 5, 6. Oh, that breaks this. Wait. Let me just make sure that's right. There's got to be a more elegant way. So I'm going to go through what I just did, and then I'm going to see if I can find a more elegant way to think through that. So if this is 1, then I get 1, 7 here. That becomes a 1 by Sudoku, right? 1 goes here in the box. 2 has to go in one of those 2 spots. So this becomes 2. This becomes a 1, 2. This becomes 1 and 2. And then we have over here, we put here. So one of these is 3. 1 can't go with 3 except put a 4 here. So 2 has to go with 3, making this 5. 1 goes with 4. No, that's fine. Why did I think that was wrong? So that was wrong. As I was doing that, I actually noticed this 6 tells me 6 doesn't go here, it's here, making that 2. And hopefully that will clear something up, but maybe not. What am I missing here? 3, 2, 3, 5. This is 2 or 5. 2, 3, 5, 8. What is this? This is still could be anything, I think. It's not 3, 6. It could be 1, 8, 2, 7, or 4, 5, as far as I can tell. This is 2, 3, 4, 5. Oh, 7, 8. That makes this 5. That makes this 3. That makes this 2, 4, 1. This is 7, 8. Something here must be done. 1, 6, 9. Oh, I broke it. What did I do? Hold on. Let's back up. 7. No. Let's back up more. So I broke this when I said this has to be 2, 3, 4, 5. Because it clearly doesn't. So so that's just wrong. This is not 2, 3, 4, 5. In fact, where does 1 go in this column? 1 has to be one of these. So this is now just a 1, 2 pair. And then I've got this 7, 8 still tells me this is 5. So this is 3. Sorry. Yeah, because this was 3 or 5. So that's 4. That's 5, 3. This goes with 1, 2 across the zipper. 3 makes this 4, 3. And then this becomes 7 or 8. Okay. Apologies for that. This is not 2. It's 5 or 8. This could still be 1, 4, or 7. I still don't know which way this is somehow. So if this is 7, this could be any of 2, 5, or 8. This is 8. This could be any 1, 4. This one can't be 4, but well, this one must be 1. So hold on. So if this is 8, that's 2, 1, 7. 8, 2, 8, 2, 1, 7. That makes this 4, 5. And we'll go this way, 4, 5. That's too much ahead. There's got to be a nicer way. I mean, that seemed fine to me, to be clear. But even if it were the right path, it's too busy. That's not 2. So that's not 2. One of these is 2. What is this? 1, 5, or 8. 3 is still. Oh, this 3 tells me where the 3 goes now. Here, and then I got 1 each from the one group is here. So one of these is 7. 2 means that's not 2. This is the 2. 2 is not here, so 2 is one of those. Could this be 2? 2 would have to pair with 5 to make 7, 1. So this is not 1. 1 makes this 2, 8. That tells me this is the 2, 5, 8 group. That's 5. 1. What is this then? This is 4, we said, with the other 2 or 5. I don't have any of those yet. This is then 1, 7. And this is 4, 5. Now this is 1's missing. So this is now 2, 7. That makes this 8, 7. 1, 4. 5 makes that 8. This is 1, 4, 7. This is 7. That's 1. That's not 1. So that's 1. That can't be 7 for this modular line. So that's 7. This is the other 5, right? But this 8 means it's 5, 8. This 5 makes this 2, 4, 5. The 2 breaks this 2. 4 makes this 4. Fixes that. This 8 fixes these. This 5 fixes these. This 5 fixes these. Holy cow. I'm just going to check it. That's right. I cannot believe it. That is a beast of a puzzle, GDC. I mean, it's very elegant, very well constructed. You're out of your mind if you think it's a 3-star difficulty puzzle. Although actually, it did take as long as I thought maybe it did to solve that puzzle. But I mean, some of that modular math is just really, I think I got very lucky happening to notice some of the things I noticed on this path. Anyway, thank you for setting. I really love this puzzle. Thank you for watching, and hopefully I'll see you again on Tuesday.